Okay, so good evening, everyone. So for today or tonight, we're going to discuss on the structural loadings, no, particularly on use or on designing or analyzing towers and other vertical structures. So last time we've discussed the structural framing system, no, from the basic classifications, no, to the most particular structural framing system used in towers and other vertical structures. Okay, so ngayon we're going to be focusing on the loadings na. Okay, so we're all familiar, no? Being able to take up your design subjects, no? Concrete and steel. And I think during those semesters that you've taken both the subjects, no, your design courses, you've able to design building or ano bang sa steel nyo, no? I don't building ba or warehouse, no? But anyway, you're already familiar with the different kinds of loads, di ba? So this will be more of a review na lang, no? So pag sinabi natin loadings, no, there are loadings, uh, parang there are there are two classifications of loadings, no. It is classified based on their directions, no. So we have the vertical loads and of course the transverse loads. Okay. So we're all familiar with vertical loads. The vertical loads are also called to be gravity loads. No, so of course these are gravity loads or forces that are applied perpendicular to the roof, floor system, or to the ground. So anything that goes perpendicular to the ground, particularly uh, going down in direction niya. These are considered to be vertical loads. So ang mga common, no, na loadings here are the dead loads, the live loads, and the fluid loads. Okay? So, alam na natin yon pag sinabi natin dead load, yun yung mga permanent, okay? Semi-permanent to permanent loadings, no? So, ito yung mga self-weight, yung weight na materials ng building mo, no, structure mo. So, kasama dito yung mga materials that are already incorporated to your structure like your superimposed dead load, no? So mga for example sa buildings nyo, no, aside from the weight of the structure itself, to consider din na dead load yung mga toppings and finishes, di ba? You also have there the utilities na nakakabit sa structure mo or sa building mo. So anything na hindi na halos ginagalaw o halos permanent na ang paglagay or pagpwesto niya sa structure mo, it is also already considered to be a dead load. Okay? So, aside dun sa mga materials na nakakabit or yung weight ng materials mo, or the self-weight of the structure itself, kasama rin dito yung mga supported, anything that is supported by the member itself. Okay? Ngayon, according to the TIA, EIA-222-G, no, this is the code that we're using again for the design of antenna supporting structures. No, according to this code, the dead load is the weight of the structure, no, and the appurtenances, including the guy assemblies and for foundation design. No. It is also the weight of the soil and the substructure is also considered to be the dead load. Okay, so pag sinabi natin appurtenances, no, later on na lang pala. Meron pala tayong definition to that. Okay, so being specific to the antenna supporting structures, pag sinabi natin dead load, kasama dun yung, aside dun sa self-weight ng tower mo, kasama din dun yung mga guy assemblies, like the guy wires, no? And also the appurtenances. And of course, yung weight ng soil and the self-weight of your foundation. Okay? So another dead load, no? This is the guy assembly dead load. And it is incorporated to the symbol D sub G, no? This is the weight of the guy assemblies. So, kasama dito yung guy wires, end fittings, and also the insulators. Okay? So, yung D sub G na we'll look at it later on sa log combinations. So, yun yung symbol niya. Different ka. Sa code kasi ni TIA, magkaiba kasi yung symbol or yung factor for the dead load, for the general dead load, and for the guy assembly dead load. Okay? Ngayon, kanina pa natin nababanggit yung ang sinasabi nating appurtenances to. So, pag sinabi natin appurtenances, this includes the antennas, no? Also the uh, antenna mounts or mount brackets, no? Yung kung makikita nyo sa tuktok ng mga towers nyo, parang may makikita kayo yung parang kamay, no? Na or mga bakal na parang branch, kumbaga. Kumbaga sa pudo yun yung mga tangkay o branch nung tower mo. So that's what we call mounts or mounting brackets. Okay? So aside sa antennas, this could be microwave antennas or panel antennas, no? Kasama rin dito yung mga transmission lines, no? So those transmission lines are also considered to be appurtenances. Okay? So aside from that, you have the conduits, no? The lighting equipments, climbing devices, yung hagdan, usually nakalagay yun sa gitna, di ba? Looking at for example, the lattice towers, no? Makikita nyo yung mga lattice towers na matataas, or even yung mga mid-rise to, there are may mga ladder yun sa gitna. And aside from these climbing devices or ladders, meron din yung mga platforms. Usually, yung mga platforms located yan for a particular number of panels. Like for example, for every 3 panels, ganun, mayroon siyang platforms. No? So, these platforms, no, kasama yung mga signs, and also anti-climbing devices, these are what we call the appurtenances. Okay, so this is in the antenna supporting towers, mga pang telecommunication towers or meteorological towers. So any towers that supports a antennas or different kinds of antennas. Okay. Of course, when we talk about the dead load, syempre, kasama din dyan or yung opposite niya is yung live load. No? So pag sinabi natin live loads, these are the imposed loads. This may change in due time or in magnitude or also in position. So anything that could be of temporary or kumbaga it is loaded on such period of time lang, no? Or pwedeng magbago rin yung location niya or yung pwesto niya within the structure or within your building. These are what we call the live loads. Alam niyo na yan. This is just a review for all of you. Okay? So of course, live loads includes occupancy loads, no? Materials, warehouse materials, so yung mga iniimbak or yung mga in-store na materials to. Also, the construction loads, so any loadings due to the or experience or loaded during the construction phase are considered to be also live loads. And other particular examples like overhead service cranes, no? So anything that is considered to be temporary to the life of the structure, this is considered to be a live load. Okay? So meron din tayong tinatawag na fluid load to. But according to the NSCP, Section 203, the fluid loads are loads due to fluid with well-defined pressures and maximum height. So, for example, you have structures that supports, for example, yung mga structures for manufacturing or for fluid storage. To. So, yung load mo doon is considered to be a fluid load. Okay? Mabilis ba? Okay naman, no? Sumasagot. Okay, I'll just continue. Bilisan tong sa part na to, okay? So if we have the vertical loads naman, no, we also have the transverse loads, no? So your transverse loads is the opposite of your vertical. So if the vertical loads are perpendicular to the ground or to the roof system or to the floor system. The transverse loads naman is applied vertically to the plane of the longitudinal axis of a configuration. So for example, if you have a tall building or a tall structure, so if it is applied vertically to the plane of the longitudinal axis, which is yung pahaba o yung height nung ano mo, height nung yung structure. So these are what we call the transverse loads. Okay, so the most common transverse loads here, we have the wind load and the seismic load. Okay, now, first one, for the first transverse load, we have the wind load. Okay, so when analyzing tall buildings, of course, using wind engineering, the wind is usually found to be the dominant load and is primarily a horizontal force. Okay, the structural systems that absorb wind loads tend to be separate to those for dead loads and other gravity loads generated internally to the building or to your structure. Okay? So, ano ba yung mga factors, no? What are the factors in calculating or computing for your wind load? Okay? So, you have there the location, no? The location of your building. Aside from that, you could also consider the occupancy or the occupancy of the building, the exposure, no? Kung ano yung nasa paligid niya, it may it be located in an urban or suburban place, or is it located in an open area or an open area near the shoreline, no? So those are the factors. The topography itself, kung located din siya sa bundok or located ba siya sa flat surface. Um, we also have the occupancy or kung ano yung use ng structure mo, di ba? And of course, kung ano yung shape. The shape is also a great factor in calculating wind loads. But we'll go on later on to the wind load. No? And again, the second um, the second common transverse load is, of course, the seismic load. So, of course, when we say the seismic load, these are the earthquake loads. And these are external force applied to a building structure or vertical structure as a result of earthquake generated agitation. So when the ground is moving due to the earthquake though, for any type of reason, no? So the building or the structure experiences this external force. So this may cause the vibration or the movement of your structure. Okay? So these are the common or the the common loads that we're going to be using in designing our vertical structures. Okay? Now, let's go on to the load combination. No? So according to an NSCP, we have here the three sets. No, we have three sets of load combination that we may use. No? So first one will be the load combinations due to the strength design or the load and resistance factor design. So if we're going to consider USD or the ultimate strength design, or if we're going for the steel, if we're going to use LRFD for our design, we're going to use this first set of load combinations. Okay, so for the first set of load combinations, we have here seven. Okay, so of course you have here the load combinations with wind, no, and of course you have here the load combinations with earthquake, no. So some of the factors here, no, hindi naman natin masasama diyan. Like for example, the hydrostatic force, no. Um, the F, kung wala naman tayong fluid wala namang fluid na kakargahin yung ating tower, no, or vertical structure. The T for the temperature loads, wala naman tayo niyan. Hindi na natin kino-consider yan, no. But other than that, these are the load combinations that we're going to use for strength design. Okay? You also have here the basic load combinations. the second set. No, these are for the allowable stress or allowable strength design. No, for if it's allowable strength design or allowable stress design, these are the load combinations that we're going to use. Okay, so usually these are used to compute for your size of your foundation. This could also be used for the load communication for your serviceability. Okay, so usually for the ASD, ito yung ginagamit nating load combination. Okay? And we also have here the alternate basic load combinations, no? So this is used or this is permitted to be designed for most critical effects resulting from the following load combinations. Okay, but of course there's a condition here. When we're going to use this alternate basic load combination, there should be a 1/3 increase that is permitted in allowable stresses for all combinations, no, including for the wind load and for the earthquake. Okay, so these are the load combinations that we're going to use according to the NSCP. Okay, but also the TIA states or gives the list of load combinations that we're going to use. Okay, so of course, for the strength limit state load combination, we have here five sets. No, five sets of load combinations. No, it's almost the same with the with your strength. No, but here you have, for example, you have the looking at the first two load combinations. No, you have the 1.2D plus 1.0DG plus 1.6W0. No, and of course the second one you have the 0.9D plus 1.0DG plus 1.6WO. So meron kang maximum value of the load, that's for the first load combination, and you have the minimum dead load. That's for the second load combination. Okay? So this is the load combination that we're going to use kapag we're going to design a antenna supporting towers. Okay? May it be a lattice tower or a guide mast or guide tower or a monopole, eh, but anything that will be supporting antennas. So these are the load combinations that we're going to use. So, pag ano na tayo, gumamit na tayo ng software, particularly MS Tower, we're going to be using particularly this set of load combinations. Okay? Because according to the NSCP, if we're going to design from the load combinations to the analysis and design of your steel members, we're going to use the TIA. Okay? All right. So let's go on. No? So the previews or itong diniscuss natin, it's just a review. Alam ko naman na you're all familiar when it comes to the structural loadings, okay? So the next part of our discussion, we're going to focus on the wind load, okay? I know your previous wait lang. Excuse me. I know from your previews from your from your previous courses that you have taken, no, wala pang nakapag-discuss ng Windows sa inyo, di ba? Tama ba? May nag
Opo.
wala pa nakapag-discuss
Hindi
ng
pa siya, hindi po siya masyadong pinupusan. So, parang nangapa po kami nung sa stream po namin.
All right. Okay. So we're going to discuss more on the wind loads today or tonight. But because our subject is structural design for towers and other vertical structures, we're going to focus mainly on the design or the computation of wind loads for the towers and other vertical structures. But of course, we have general provisions that are used to all of the vertical structures. Okay? So, okay? So for the wind load, we're going to refer to the section 207 of the NSCP volume 1, the 7th edition or the 2015 edition. No? So the section 207 discusses the wind load provisions of the chapter 2 minimum design requirements. Okay? So the wind load provisions of the NSCP 2015 are generally referenced from the wind load criteria of ASC publication. Okay? So yung pinagbasehan ni NSCP for the wind load provision, no, for the 2015 edition is the ASCE 7-10. Okay, so yung 7-10 is published in 2010, no. But of course, the NSCP 2015 is being prepared, no, before 2015. I think the 2015 edition of NSCP was published in 2016. No, I don't know if it's the later part of 2015 or the earlier part of 2016, but of course during those times. And when the NSCP is being prepared, no, or being compiled, of course uh, our codes or most of our codes are adapted or reference from the foreign codes, particularly American codes. No? So during those times, ang pinaka-latest pa lang for the minimum design loads ni ASCE is yung ASCE 7-10. Okay? So the 7-10 is the publication, includes the minimum design loads for buildings and other structures. So sa darating na bagong edition, the 8th edition of the NSCP, which will be published hopefully by 2022 next year, according to the ASEP. No? I think the version of the ASC that they will reference to is this the 716, the ASC 716, or the more or the later publication or later edition for that. Kasi I think after the 716, parang meron pa atang mas bago. 7-20 yata, if I'm not mistaken, no? At basta alam ko, may mas bago na doon. And I think yun na yung gagamitin ni NSCP. So, more on ang mga generally ang mga provisions like that is yung mga revisions or mga updates dun sa bagong ASCE will be on the provisions of wind load and of course the earthquake. Sa earthquake naman kasi the NSCP 2015 is using provisions from the UBC 1997 or the Uniform Building Code of 1997, but they're going to be referring to the ASC na for the computation of the earthquake. So doon na rin siya naka-base, hindi na sa UBC. So wind naman, of course, ASC pa din, but I think to be more specific to the design and computation for antenna supporting towers, TIA pa rin yung gagamitin ni NSCP. Okay? So according to the 207.1, the buildings and other vertical structures shall be designed and constructed to resist wind loads as specified and presented in the section 207A through 207F. Okay? And of course, kanina ko pang sinasabi, when it comes to the computation and the analysis of antenna supporting structures, we're going to use, of course, the TIA. So particularly the TIA or the ANSI-TIA-222-G-1 -205. Okay? Entitled the Structural Standard for Steel Antenna Towers and Antenna Supporting Structures. No? So there is also addendum for that. The ANSI TIA-222-G-1-207 and another addendum or the addendum number 2, the ANSI TIA-222-G-2-2009. So yung mga addendum niya was added a few years after the publication of the TIA-222-G, which is published in 2005. Okay? So the buildings and other structures, including the MWFRS or the main wind load force resisting system, and the CNC, which is the components and cladding thereof, shall be designed and constructed to resist the wind loads determined in accordance with Section 207 through 207F. Okay, so the provisions of this section define basic wind parameters for use with other provisions contained in this code. Okay. So ano ba yung mga permitted procedures for the computation of wind load? Okay. So for the design wind loads for buildings and other structures, para sa MWFRS and CNC elements shall be determined using one of the procedures as specified in this article. So ano ba yung mga article procedures na yun? Okay? Now, for the MWFRS, okay, pag sinabi natin yung MWFRS, these are the loads that are placed or that is computed for the placement of wind loads sa different part, no? Different areas or different parts of the main structures of your buildings, okay? So this could be a wind load in the roof, no? Or wind load in the wall. So the roof and the wall are of course part of your basic structure of your building or your other structure. Okay, so this is the MWFRS. Okay, now for determining the wind loads for MWFRS, we have two procedures that is allowed by the NSCP. Okay, you have here the directional procedure for buildings of all heights, as specified at Section 207B for buildings meeting the requirements specified therein. Okay, the second procedure that is allowed for determining the MWFRS of the wind load is the envelope procedure. No? So, itong envelope procedure, basta ginagamit lang siya sa low-rise building. No? And the envelope procedure is specified in the Section 207C. Okay? So, dating code, the NSCP 2010, this is called the simplified. Kasi mas ginagamit lang siya sa low-rise, no? Or there's a criteria for that, no? So, kung pasok yung structure mo sa criteria niya, you could use the simplified procedure or the envelope procedure. Okay? So, there's another procedure, what we call the directional procedure. But these are for the building appurtenances. Okay? So, yung mga equipments or mga rooftop structures or equipments located at the rooftop and other structures. So, dito papasok yung solid freestanding walls, also the solid freestanding signs, the chimneys, the tanks, the open signs, and of course the lattice frameworks and truss towers. So these are specified in the section 207D of our NSCP. So dito lang tayo focus, okay? So for our course, for this course, we're going to focus only on this directional procedure. So sa section 207D lang tayo magpo-focus ng ating computation. But of course, for the general provisions, we have the 207A. Okay? So the general provisions which are used for all types of vertical structures. Okay? And lastly, you have the wind tunnel procedure for all buildings and all other structures as specified in the section 207F. Okay? Now, after the MWFRS, of course, we have the CNC, or what we call the components and cladding. Okay, so with computing for the wind loads for the CNC of all buildings and other structures, we have one of the, or you could use one of the following procedures. Okay, the first procedure, you have the analytical procedure provided in part 1 through 6 of the section 207E, and the wind tunnel procedure as specified in section 207F. Okay, so we have here a flow chart, no? So of course, ito yung kanino ko pa mention. This is the section 207. Okay? So of course, before we compute for the... Okay, paano ba ito binubura? Ayan. Of course, before we go on to the equation or for the computation of our wind load, we need to determine all of these requirements, all of these general provisions, which is located at the section 207. Okay. Of course, you have the basic wind speed, the wind directionality factor, the exposure category, topographic category, the gas effect factor, enclosure classification, and of course, the internal pressure coefficient. Okay, so these are the general requirements, both used for the MWFRS and the CNC. And of course, gagamitin na natin when we're going to compute for the wind load of towers and vertical structures. Okay? But of course, pagdating sa procedure, no, pagdating na sa computation mismo ng ating wind load, dito lang tayo magpo-focus. Okay? So dito lang tayo sa section 207D of the directional procedure for building appurtenances and other structures. Okay? And of course, if we're going to compute also for the CNC of our vertical structures, we will focus on the section 207. Okay? So that's for the components and cladding. Okay? Itong mga section lang importante sa discussion natin, no? We're not going to be focusing on the with loads for buildings, no, kasi we don't have much time for that. Kasi after this discussion, no, after we discuss the provisions of the NSCP, we're going to have an example, no. Our first example will be a billboard. No, we're going to discuss it next meeting. And after the example of the billboard, we're also going to discuss the provisions from the TIA specifically. And after that discussion on the provisions of the TIA, we're going to have an example of computing the wind load, particularly a lattice tower used in telecommunication. Okay, so will be for our the upcoming discussions. Okay, now for the sign convention, mapapansin nyo, when you're going to compute for the pressure or the wind pressure, you're going to encounter positive and negative pressure, okay? So for the sign convention used in the NSCP, you have the positive pressure that is towards the surface. Okay, for example, you have a roof, no? Meron kang gable roof, and that particular pressure or that particular wind pressure is towards the surface. Okay, so yung value ng wind pressure mo na yun will be positive. Okay, and the negative pressure is away to the surface. Kasi yung negative, yung wind pressure na negative na yun is palabas. Okay, so ito yung ito yung inassign na sign convention ng NSCP for the wind pressure na mako-compute natin. Okay? So anything or if the wind pressure is going towards the surface, the wind pressure should be in positive form, and if your wind pressure is acting away from the surface of your structure, that should be in negative pressure or in a negative form. Okay. Now, when it comes to the critical load condition, the value of external and internal pressures shall be combined algebraically to determine the most critical load. Okay? Let's go on to the wind hazard map. Okay? The basic wind speed or the V used in the determination of design wind loads in buildings and other structures shall be determined from the figure 207A point 5-1 as follows, except for the provided in section 207A.5.2 and 207A.5.3. Okay, so for every category, you have a figure assigned to the for the determination of your basic wind speed. Okay, so for the occupancy category 3, 4, and 5, we're going to use the figure 1A of figure 278.5. Okay. Pag category 2 naman, we're going to use the 1B. And of course, for the category 1, we're going to use the 1C. We already discussed this no, yung occupancy categories nyo during your discussions on earthquake. No? So we're not going to, di na natin isa-isahin yung mga categories na yan. No? Okay? And of course, the wind shall be assumed to come from any horizontal direction. The basic wind speed shall be increased when record or experience indicate that the wind speeds are higher than those reflected on this figure. So, for example, a particular area, Mamba, dito sa Palawan, ang design or ang basic wind speed dito is 200 kilometers per hour. No? And huwag naman po sana mangyari, no? Pero if ever na nagkaroon ng experience ang Palawan to have a storm which has a wind speed of more than 240, o pwedeng gamitin yung recorded value of the wind speed for that. Pero sana wag naman mangyari sa atin dito yan sa Palawan. 240 is already strong enough, no? Okay. So we have here the figures, no? So this first figure, we have the basic wind speeds for occupancy, category 3, 4, and 5. Okay? The next one is for the category 2. Wait. And the last figure is for the category 1. Okay, so you can refer this to the NSCP now if you're going to determine the basic wind speed of the location of your project. No, but there's a website and internet is in tlubal.com. No, there is a digital map determining the basic wind speed. No, buksan natin. Ay, nakikita pa ba?
Nawala po yung presentation, ma'am.
Saan nawala? Doon sa map?
Opo, sa last na category po.
Sa last category lang. Sige. So the last category or the last figure for the figure 207.5 is the wind speed for the category 1. Okay. So there's a website again that shows digitally the basic wind speed for every location of your every location in the Philippines and for every category, no? So pwede natin itong buksan. Wait lang. So this is a website. No, i-share ko na lang sa message sa chat room ng ating meet. So you could see it for yourself. Pwede nyo explore on your own the website. Okay, like for example, halimbawa so makikita nyo there's a certain color for every value of the basic wind speed. Okay, so from the 240, medyo hindi na naglo-load. Ayan. From the 240 going to the 340. No? So mapapansin nyo yung 240 dito sa Palawan. So the most western part of the Philippines is assigned to the 240 sa pinakamababa. Okay, so hanggang papunta sa eastern side, no, of the Philippines, mas palaki ng palaki yung value ng ating basic wind speed. And of course, for every category, nag-iiba rin yung value niya. Okay? So, for example, for the category 3 and 5, or the occupancy category, so nag-iiba din. Medyo hindi lang naglo-load yung colors, no? Okay? Hindi lang lumalabas. Lumalabas ba sa inyo?
Hindi rin po.
Hindi lumalabas na parang bagal yata. Bagal yata ang internet ko. Kanina lumalabas, di ba?
Kanina, ma'am, yung una lumabas.
Lumabas.
Pero nawala.
Alright. Ayaw pa rin talaga lumabas sa akin. Kahit anong ano ko. Anyway, you could look at the group chat or the chat room of our meet. You could save the link and you could explore the website on your own na rin naman. Para makita nyo din. But of course, the NSCP naman is providing the map for that. Okay? So you could save this link, copy-paste nyo na lang. But this is the link na binuksan natin kanina. Okay? Now, so of course, there's also a provision for special wind regions. No? For the mountainous terrain, gorges, and special wind regions shown in the figure 2078.5 shall be examined for unusual wind conditions. Okay, the authority having jurisdiction shall, if necessary, adjust the values given in the figure to account for higher local wind speeds. Okay, so gaya na sabi ko kanina, if ever na the particular location experience a higher value of the wind speed comparing to what is indicated in the map, no, pwedeng yun yung gamitin. Okay, of course, especially for the special regions like mountain terrains and special wind regions. Okay, for the estimation of basic wind speeds for regional climatic data. In areas outside the cyclone-prone regions, regional climatic data shall only be used in lieu of the basic wind speeds given in the figures when one, approved extreme value statistically analysis procedures have been employed in reducing the data. Two, the length of record, sampling error, averaging time, anemometer height, data quality, and terrain exposure of the anemometer have been taken into account. Of course, reduction in basic wind speed below that of the figures shall be permitted. Okay. Para naman sa tropical cyclone-prone regions, no, the wind speeds derived from simulation techniques shall only be used in lieu of basic wind speed given the figure when approved simulation extreme value statistically analysis procedures are used. So, kung wala naman tayo available data for that, we'll still be sticking to the values indicated in the figure from the NSCP. Okay? So in area outside tropical cyclone-prone regions, when the basic wind speed is estimated from regional climatic data, the basic wind speed shall not be less than the wind speed associated in the specified mini recurrence interval, and the estimate shall be adjusted for the equivalence of to a 3-second gust wind speed at 10 meters above the ground in exposure C. Okay. So of course, while using the wind hazard maps, no, or our figures in determining our basic wind speed, there are also some limitations. Okay, so from section 207A.5.4, the tornadoes have not been considered in developing the basic wind speed distribution. So include na nito sa ating code. Of course, hindi naman uso sa atin yung tornadoes eh. Hindi naman siya ganun kadalas na na-experience dito sa Philippines. That's why it's disregarded in developing the distribution of the wind speed here in the Philippines. All right? Now, we go on to the wind directionality, no? The wind directionality factor or the KD. So KD yung ginagamit nating symbol for our wind directionality factor. So to determine the value of the wind directionality factor, we're going to use the table 207A.6-1. Okay. The directionality factor shall only be included in determining wind loads when the load combination specified in section 2.3 and 2.4, yung pinakita natin kanina. Kung yun yung gagamitin na load combinations, we're going to be determining our wind directionality factor KD using the table 207A.6-1. Okay. So the effect of wind directionality in determining wind loads in accordance with the section 207F, that's for the wind tunnel, no, shall be based on an analysis of wind speeds that conforms to the requirements of 207A.5.3. Okay, so this is the table 207A.6-1 from NSCP. So you have here the values for directionality factor, no, for every structural type. Okay, so pag buildings, yung project natin, for MWFRS and CNC, we're going to be using 0.85, both for the, of course, the MWFRS and the CNC. Isa lang yung value. Okay, and if you're going to be computing wind load for arch roofs, you also have the 0.85 for the directionality factor. For the chimney, tanks, and similar structures, so we have two. No, we have two different values for that. So for the square, you have 0.90. For the hexagonal and the round, we're going to use 0.95. Okay? So ito na yung much nakafocus sa ating course, no? For the solid freestanding walls and solid freestanding and attached signs, we're going to use 0.85. For the open signs and lattice for framework, also 0.85. Okay, and lastly, for the truss towers, for the triangular, square, and rectangular, if the cross section of our truss towers falls on this tree, no, we're going to use 0.85. But kung hindi siya triangular, square, or rectangular, we could use the 0.95 for the directionality factor. Okay? So, for determining the directionality factor, we're going to use the table 207A.6-1. Okay? Now, let's go on to the exposure. Okay, pag sinabi natin exposure, ano yung nakapaligid doon sa structure ng ating building. Okay? Now, for each wind direction considered, the upwind exposure shall be based on the ground surface roughness that is determined from the natural topography, the vegetation, and constructed facilities. Okay? Now, for the wind select for each selected wind direction at which the wind loads are to be determined, the exposure of the structure shall be determined for the two upwind sectors extending 45 degrees either side of the selected wind direction. Okay, so you have here the surface roughness category. No, so before we could determine the exposure category, we need to determine first the surface roughness. No, so you have three. No, you have the surface roughness B, C, and D. Okay, for the first one, the surface roughness B, so this includes urban and suburban areas, wooded areas, and other terrains with numerous closely spaced obstructions having the size of single family dwelling or larger. So sa mga bayan, sa mga cities, no, even in sa mga kakahuyan, no. So anything that is or have a much more obstruction, no, we're going to use the surface roughness B. Okay. Sa C naman, the surface roughness C, this includes the open terrain with scattered obstructions having height generally less than 9 meters. Okay, so kasama dito yung mga grassland, no, open areas, mga country lands, no. So this kind of areas falls under the surface roughness C. And lastly, the surface roughness D includes the flat, unobstructed areas, and water surfaces. This includes mud flats, salt flats, and unbroken ice. Wala naman tayong ice dito sa Philippines eh. So basically, dito sa Philippines, considered yung mga beach, no, sa mga malapit sa shoreline. No? Kung yung tower mo nakatayo sa malapit sa dagat, o malapit sa open water area, so your surface roughness falls under the category D. Okay. Now, we've already determined the different categories for the surface roughness. We could now determine the exposure category. Okay? So, pag sinabing exposure B, no? So, align lang naman yan sa ano eh, kung ano yung surface roughness mo. Okay? So, usually the exposure B is used if your structure falls under the surface roughness B. Okay? Sa C naman, if your surface roughness doesn't fall or the exposure exposure of your building doesn't falls on B or D, so of course, consider na yan sa C. So, di ba yung surface roughness C natin is the open land, the grasslands, no, country lands, no. So, this includes in the exposure C. Okay? And lastly, the exposure D, of course, sa mga areas, sa mga shorelines, no? So again, the area of shorelines falls under the surface roughness D. So ang magiging exposure no wind exposure mo will be a exposure D. Okay? So after determining our exposure, no, of our exposure categories, so we could now go on to other requirements regarding our exposure. Okay? So for the directional procedure for building appurtenances and other structures, so this is the section 207B. So hindi ko na in-include yung yung for the buildings, particularly for the building, no? For the directional procedure, building, and for the another one, another procedure. So discuss lang natin yung para sa appurtenances and other vertical structures. Okay? So according to the 2078.7.4.3, okay, so the wind loads for the design of buildings appurtenances, such as rooftop structures and equipments and other structures, as specified in 207B, shall be based on the appropriate exposure for each wind direction considered. Okay, so the figure C 207A.7.5 shows the determination of wind loads from different directions. Okay, so mapapansin nyo, you have here 8. Okay, so of course, a circle has a 360 degrees. So if you have 8 parts, you have here 45 degrees. Okay, so for your towers and other vertical structures, you're going to determine the wind loads in 8 parts. Okay, so you have a wind load from the 45 degrees, no, from the north, from the north of your building, then to 90 degrees, okay, to 135 degrees, and so on and so forth. So that will be for every 45 degrees. So basically, yung magiging wind load nyo will be more than one case. Okay, so of course, if you have 8 parts for that, ang generic na case mo for your wind load will be 8. That this could be more than 8 pa eh. Di ba? But generally, you have 8. So yung magiging load combination mo, no? For example, you have the load combination 4. So the load, for example, the load combination for the strike design. So for example, yung load combination 4 mo, di ba meron yung wind load. So kung 8, you have 8 wind load cases though, you also have 8 of the load combination 4 for that. So yung load combination 4 mo na yan, dadami pa yan up to 8. Kasi you're considering one load case sa isang load combination. So if you have more than one, or let's say 8, no, yung general load combination for the wind load, according to this provision, no, so magiging 8 din yung load combination mo na 4. So, kung ilan yung load combination mo na may with load, ita times 8 po pa yun. So, ganoon kadami magiging load combination natin. Okay? So, next meeting, we were going to continue discussing wind load, no? Hanggang sa from the continuation of the general provisions of our wind load up to the procedure or the directionality procedure, the section 207D. Di ba? So after that, pag natapos natin lahat na yun, we're going to have an example. Okay? So, that will be next meeting sa Tuesday. No? And, ngayon kasi hindi nakapag-schedule for the class observation. So, maybe